Hello guys, so we are going to continue the discussion with respect to derivatives, and in this video we are going to discuss about derivatives of trigonometric, logarithmic and exponential function. Now here we are not going to derive any of these formulas in short, but I will just try to show you that how you can come to a conclusion in understanding the specific derivatives. First of all, we'll go with trigonometric function, and then further we'll go ahead and see the formula of logarithmic and exponential functions. Okay. So here what we are basically saying is that whenever we talk about trigonometric function, let us take two function, f of x is equal to sine x, okay, and f of x is equal to cos x. So here in my x-axis I have x, in the y-axis I can have sine x or cos x. If I am considering sine x, the curve will look something like this red color, right? And if I take cos x, it is nothing but it is basically this green color of curve, okay? Now let's observe any one of them, and our main aim over here is basically to calculate the derivative of sine x. So if I want to find out the derivative of sine x, and similarly I want to find out the derivative of cos x. Now observe this, okay? So let's focus on the sine x right now, okay? Let's consider some important points over here. So this will be one point that I really want to consider. Let's consider this point. And if I probably draw a slope, it is going to be 0. Again, for this particular point, if I draw the slope, it is going to be 0. And for this particular point, it is going to be 0. And for this particular point, it is going to be 0, right? And you can clearly see that because I have a horizontal line, right? Horizontal tangent line. And for this, you know that my y value is going to be 0. So here is my y value that I'm coming for 0. For any x, it can be any x over here. Similarly, here also my y basically means my function f sine x is basically giving me 0, right? Similarly over here, the output is 0. For here also, the output is 0, right? And similarly, if I consider the other line, let's consider this specific line. Let's say here, if I try to calculate the tangent for this point, okay? And let's say this is my point, and I will just go ahead and try to draw this point. And this point, whenever for this x value, we are trying to calculate the derivative, right? So I'm definitely going to get it as -1 because the steepness is very high, right? So this will definitely be -1 because why? Because this is a negative slope. This is a negative slope, right? Negative slope. So here you can see that my output is going to be this specific value, right? For this x, I'm going to get this f of x. Similarly, if I go ahead and see with respect to this slope, right, over here, you'll be able to see I'm going to get a positive slope. Similarly, for this, I'm going to get a negative slope, okay? And for this, I'm going to get a positive slope, okay? So that is what we are specifically doing. Now, let's focus on the green color curve also. The green color curve basically shows us cos x. Now, do you see for sine x, when I am getting this, for this particular x value, I'm getting the slope as 0. So do you see with respect to sine x, your cos x is also it is coming at the same, it is just like overlapping, right? These specific points are basically overlapping, right? And if I also consider this here also, you can see it is overlapping, right? So my let's say if the x value is 0 over here, if I'm trying to calculate this particular slope over here, I'm going to get it as -1, right? And similarly for this sine x, right? If I'm trying to calculate the derivative, you can see that I'm getting the cos x value, right? So here we can go ahead and write the derivative of sine x is nothing but cos x. And similarly, the derivative of cos x is equal to sine x. Why I'm writing this? Because see, let me just go ahead and write it again. The derivative of sine x is equal to cos x and derivative of cos x is equal to sine x, because it is very simple. For every value, let's say for this particular value, when my x value is this, if I'm trying to calculate the slope, it is coming over here. And here it is nothing but it is just cos x for this same value, right? So that is the reason we are writing the derivative of sine x is equal to cos x, and similarly derivative of cos x is equal to sine x, because for this value you can see that my derivative is this value, and that is where your sine x is basically passing, right? So these two conclusions you can actually come from this specific curve, right? And again, just by seeing this curve, you can actually come to a conclusion, you can think like how your functions may look like, okay? Now, let me go ahead and, this was about trigonometric function. So let me go ahead and write over here. So this was about my trigonometric function. Similarly, for other functions like tan h, secant s, tan h, cosine x, like you have different trigonometric functions. You can just see the curve and you can come to a conclusion. Now let's go ahead and talk about the logarithmic functions. So here, the second one that I'm actually going to talk about is logarithmic function. Again, in order to understand logarithmic function, I'll give you this as an assignment. Just go and see the curve. Okay, just search in Google like plot logarithmic function. And here, logarithmic function basically says if your f of x is log of x, then your f dash x, that is derivative of x, is nothing but 1 by x. So this is what your logarithmic function basically say. Again, as I said, I'm not going to derive this because it will not be very important for us, because at the end of the day, you really need to understand the application part. Similarly, if I go ahead and talk about the exponential function, here, if I go ahead and write my f of x is equal to e to the power of x, then my f dash of x is also e to the power of x. This is one amazing derivative, right? If you really want to find out the derivative with respect to e to the power of x, I'm also going to get this specific value. And already we have also discussed about with respect to constant value, right? With respect to constant, we have written if f of x is equal to c, then f dash of x is equal to 0, right? So we know this as we have already discussed. And final one is specifically with respect to power rule, which we have discussed earlier. So I'm also going to go ahead and write out over here, if f of x is equal to x to the power of n, then f dash of x is nothing but it is n multiplied by x to the power of n minus 1. Please make sure that you remember this. And I hope everybody, if you have done at least engineering mathematics or high school mathematics where you had all these things, I think you should be able to understand. So I hope you like this particular video. This was it from my side, and here in this video we have discussed about the derivatives of trigonometric, logarithmic and exponential function. This kind of curves we may get with respect to our data set, which will be important whenever we try to find out a derivative with respect to this. So yes, this was it from my side. I will see you in the next video. Thank you.